everybody. Welcome to episode 68 of CodeRushed. Mark Miller here. Rory is still taking a break. He's on vacation. Looks like I've got some green screen adjustments I need to make here in the background. That is seeming to improve it a bit. So we won't see Rory, I think, till Tuesday or Wednesday next week. So he's going to be missed. As always, that British voice of sensibility to keep us on track is not here. However, I have a strong feeling that Will Bennett will be here to guide us. He may even be here out in the chat room right now. Yep, there you are, Will. Hello and greetings to you. So Will Bennett says, those are some sexy particles. We're getting there. We want them to, today I hope to give velocity, acceleration, and some motion to these. And even if we make some good progress, I think we should be able to even get orbiting around a particular point. I don't think that the math on that is going to be too hard. So we're looking to get there, and so that's what we're going to do. I just checked in my current code. It is marked out here with this tag right here, episode 68 begin. I'll put this in the chat room as well, so if you want to take a look at that, you can. As usual, that code contains everything that we've written here, however, it does not contain the actual assets because of copywriting licensing issues. So there's that. The one thing I did between yesterday and today's show is I created a new class called Dragon Game. And Dragon Game, I built this because of the time it was taking to load up the regular overlay. It was taking a long time to do that. And so now I've got Dragon Game here, and Dragon Game basically has yellow seeds, yellow flowers. Looks like we don't need the portal game in here, the portal background. It's got a background banner, but the background banner does not appear to be drawn anywhere, so I don't think we need that either. No references there, so we'll go ahead and remove that as well. So it's basically just a super cleaned up version of the drone game, with the exception that it still has the CodeRushed rocket, which is in the upper left there, that we can launch off once we switch to the normal screen view. And it's got the emitter that we built yesterday in it. So it's got the emitter and it's got seeds in it because Will Bennett, a regular out here, often will give us suggestions and likes to call my attention in a subtle way by dropping a seed. And I hear the sound of the planting, or I can see it on screen, and I'm like, oh yeah, what do you need, Will? Will says in the chat room, I sent you a whisper. Don't know if you've seen it. I did see it. I thought it was, I was looking at it and I thought it was great. I'm looking for it, but I don't see the link. I can click it up here, bring it up here again. Let's get that. Here we go. So Will has sent us basically a description of how to do overloading on the methods. So we can have a method called add1 that takes a vector, but we can have methods of the same name that take all of these other parameters. And notice the declaration on this. We're basically saying these are all my overloads, right? So they're talking about these are all the parameters that I can take in. And based on which one is there, it looks like I am needing to do some checks on those pieces. Is param1 an instance of vector? Otherwise is if delta y, otherwise it's the other overload. So they make you work for it, but that's apparently that's the syntax for doing overloads in there. Yesterday when I was asking about overloads, just to be clear, I was asking about operator overloads. I wanted to overload the operator plus to see if that existed, because I wanted to be able to say vector1 plus vector2 instead of making an explicit call to the add function. So that's kind of what I was more looking for. However, this is still useful information for folks who want to do overloads. I did not know this. I am new to JavaScript and TypeScript. I've essentially been working on it since this show, and that's it. Yeah, no, Will Bennett says in the chat room, no operator overloads. Will Bennett also tried to send the command seed, but that doesn't work in this view. However, if we switch back to the other view, What's going to happen here is the question. Looks like I'm having all kinds of minor green screen issues here. Just doing some adjusting. That seemed to take way too long. Let's look at our code. Looks like we're doing the full load of the regular. And I think because it's in main, that's the last change I didn't make, which is this. So there at least you can see how long it took. It took, I don't know, about 20 seconds for that to load. Sometimes it takes longer. I believe the time it takes to load has to do with how busy my computer is and how quick the hard disk access is. Because it's by far the biggest thing this thing is doing is it's loading in megabytes, what's likely to be megabytes and megabytes of assets. So we get all the drones flying, the seeds falling, the plants growing, all of that we've built up so far, the coin spinning, all of that is through a liberal use of assets. Right above me, you see our first test on the particle system right there. I'm going to now comment out this line of code, and we're going to stop loading up the drone game. Instead, we're going to start loading the dragon game, and we're testing this out for the first time. So I'm going to save that there. I'm going to change the views and restore back here, and we'll see how quickly it comes in, if at all. It looks like maybe it's not coming in, so we might need to do a test on this. Looks like I'm also not running from back here. Oh no, here we go. It's coming in. So what's interesting is it's still, why is it taking so long? And why did it still create a drone game instead of a dragon game? That doesn't make sense to me, because now that means I can type in drop. Whoops, not here. I can type in drop over in the chat room, and a meteor should drop down. Yeah, there it goes. So it looks like that commenting out did not work. Let's try maybe it's because I haven't compiled it yet. So let me try a compile on this. Let's do a run and get this started. And I think before I do that, just to be safe, I'm going to kill out all instances of Chrome and then start them back up again, because we often will have that problem here. And let's go ahead and start. And let's see if that changes it. Yeah, I have a feeling it could have to do with the cache piece that's out there. It may have been caching this, although that doesn't really make sense, though, because it wouldn't cache the TypeScript files unless the problem has to do with, well, let's see. Looks like we're reloaded. And are we, oh no, we're still compiling here, sorry. The compile is right there. There's the compile right there. Yeah, I'm just noticing because of the red color we chose with our particle system as our first test. It would not be hard to make this simulate a blood splatter either. So kind of interesting. All right, let's see what happens here. Here comes this one right here, loading up, and maybe we've got some errors. Okay, splat.mp3, cannot read property, changing direction of undefined. Looks like my problem is, yeah, drag it in, start, select planet, set active planet, my rocket. Is there. Okay. All right, so let's fix that. So over in drone game, I've got a my rocket. And in dragon game, I changed that to my rocket too. But I'm going to change it back to my rocket and delete the declaration here. I think I'm going to do the same thing with this and delete the declaration there. We're just going to use those over from drone game. And let's come over here and refresh and see if that fixes it. That looks like that fixed it. And it loads much faster than we've seen before. So good. And we should be able to fly. So if I type in launch, so we should have minimal functionality. Oh, We should, but let's see. What do we got here? Okay, there's my splat not found. We need to finish draw of undefined gravity games dot draw. This dot planet surface in gravity games. Let's see here. Let's look at drone game and look at gravity games and see what's going on inside of it. There's the draw. Initialize is here. That's in drone game. Let's go look at our initialize in dragon game. Oh, we are building it here as well. Okay, good. Okay, where else? Start. Let's see what's going on here. Dragon game start. We got the same thing over here, so that should work there. This might be our problem. I think I may have taken that line out. Did I do that? Dragon game in launch. Nope, I've got a gravity games.new game there as well. So what is my problem? Let's go look at the arrow again. The planet's surface is not being initialized, so let's go look at gravity games. Plural, gravity games TS. Okay, planet surface. Set active planet. Here's my problem. Right here. Okay, so I need to do something like this. If it's an instance of drone game, then we can work with all meteors, all seeds, and bees yellow like that. If it's an instance of dragon game, like that, then we're only working with the seeds. That's the only thing we have in there. And then everything else I think should be the same. Looks like I need a closing brace right there. Okay. And I think that might fix it. Let's see if that fixes it. So let's do a refresh here. There's that. Let's send the launch command in. Nice. And so now we have, now I should be able to say go right. And the drop command should do nothing. Yeah, it does nothing, but the seed command should work. And there it is. So now we have a much faster refresh. So now if we, so that is our dragon game. And now if we come back in and we change our view for the live stream and then restore it back here. Yeah, no drones, Will. We took out the drones as well because I wanted it to load as quickly as possible. So we have a really fast edit, test, compile cycle. And then it's one line of code to switch back to the other one to do the full test with the drones and everything like that. So looks like it's not working. So let's try a refresh on over in the inside of...
Sad Panda!
Yeah, maybe a little sad. Whoops, that I did not want to do. Hold on. I hate this, by the way. If I'm, notice I have a UI here where I want to scroll up and down using the mouse wheel. But if I'm scrolling that mouse wheel down and I happen to be over one of these, look what happens. It changes the values unintentionally just because I want to navigate, right? If I'm here, everything works as possible like I want, but if I'm here, I'm destroying things. So I don't see it. I will destroy things. And unfortunately with OBS, there's no undo. So if I were to hit OK here, I would essentially be creating permanent data loss, and I would have to go back and restore it by figuring it out. So I have to cancel here a second, bring that back up again. So just a little moment there to talk about UI. I've seen this also with software from Adobe. The same mistake. Needs to be very careful about the way this works. Let's go down to this. I'm going to click this button, refresh cache of current page, and see what happens there. See if that's enough. and that's all it needed. It just needed to refresh the cache. So it was, for some reason, it wasn't taking those changes we were making to main.ts weren't really activating. But now it looks like it's active, and now I can come in here and type in launch, and I can type in seed, and it drops a seed, which grows to a plant. But if I type in drone or anything else, it's not going to work. So that's cool. So now we've got a faster edit, test, compile cycle. I should be able to type in doc as well. Nice, and we're docked. So, so pretty good. I feel pretty good about that. So that's a nice little testing bed that we have created here. The next thing I want to do is I want to go into velocity, and I want to add velocity to both the particles and to the emitter. And in order to make this look real, we've got to do it to both. But if we add it to the particles, if we add it to the emitter, it's just going to look like what you're seeing above, just essentially statically unchanging as it moves, across the screen. What I want to do is I want to add it first to these pieces right here. And I maybe also want to give them a lifetime, and I want to start, shooting stuff out, producing stuff. So I guess let's do this. Before we add velocity, let's add a lifetime to the particles, and let's honor our particle per second property that we added to the emitter that we haven't written any code for yet. So we'll do those two things first, and then we'll add velocity and gravity to it next. So that's inside our game engine. We've got our emitter right here. And right now we've got this hard-coded add particles call, which I think is coming from right here. We're just starting right out. I'm going to comment this line out. I don't want to add particles anymore to it. And instead, I want to, in essentially update position, I want to come in, and I think I'm going to maybe change this to just update instead of update position, because it's not just positions, we're actually going to create particles here as well. So we want to check to say, we want something like this. If not a last update time, then no. If last update time, I think I want to do this. So if we have a valid last update time, which we set once we've done an update. So the first time we call an update, I think I'm going to do nothing. There's going to be no particles at all, is what I think I'm going to do. Then the next time we come in, I'm going to check to see. I'm going to basically say, okay, seconds since last update. And that's going to be equal to now minus this dot last update time, like that. And as I write this, I think about the code Will sent us, and he was suggesting that, oh, by the way, check it out. Will just tried it, Planet Sun. I don't think there's any screen update. I'm not seeing that, but I wonder if we drop a seed out, if it's going to drop down really fast. Yeah, so we're actually able to change gravity even though we're not actually seeing the sun being drawn right there. So so we can do that. Okay, so second since last update. The thing I was saying that I didn't finish is that I think Will was suggesting in his version of this is that we calculate this on the outside and pass it in right here. So if this gets heavy in terms of I see this code calculation showing up, 2 or more times down here in the code we're about to write, then I will say, yeah, let's go ahead and do that. In fact, actually, I can see it's going to be heavy already because we're going to come down in here and do it. So let's go ahead and let's get out. Let's look at the call to this. And let's set our last update time here. And let's set it down here at the end of this. Last update time is equal to now. Like that. And let's declare that. And it's got it as a number. I'm going to rename yellow flowers 1 to just yellow flowers. We don't need that like that anymore. And then let's pass in last update time as a number. I'm going to use the VN template from CodeRushed. It adds a comma for me automatically. VN means variable type number, so it types in number for me automatically. I don't have to do anything there. So now, if last update time, and now, wait. Let's do this, though. Let's ensure that last update time is always good. And we'll do that by, can we do that? Does that make sense? What I want to do is I want to set it in the constructor, is what I think I want to do. No, I don't. I want to set it, hold on. Let's go look at main. I want to set it in start is where I want to set it. So I want to say here in the Dragon game that we're going to say last update time is equal to PFN. That's another CodeRushed template for performance.now. And so I'm going to say that. And I know that in truth, it's not, it hasn't actually updated. But in terms of calculations, I want to basically say, here's the, I want to give it something so that all my code always is going to have a valid last update time. In the update, you can do, if not last date update time, then last update time is equal to now. I see that, Will. I don't like that. I don't want to do that because I don't want to, even though it's probably incredibly fast and there's no noticeable performance difference, I have anxiety about putting that conditional check in every single time. That's only going to be really useful the first time we go in there. So instead, I'm going to do it in start. That's what I'm going to do. So the downside is if there's significant delay between start and the first time we call update screen, which is unlikely but possible, then what will happen is everything will kind of be already jumping in a moving position, and we might see that at the very beginning of the game. However, for everything we're doing, that's not going to be a big problem, and this is my preference, so I'm going to go in this direction right here. Although I think the Will's suggestion is equally valid and totally fine, and from a performance standpoint, totally likely to be have no impact at all on what a human could see or not with regards to it. Okay, so let's see here. My update is here. There's my last update time. Okay, this is in my emitter. Let's go back here. Yeah, okay, I'm good. All right, so there's my emitter, and then what I want to do is in update position, I want to call particles, and I want to call update here, rename that to update as well, and then let's just pass in last update time there. Let's pop down in there, use VN again, paste in last update time, and then we're good. So we don't have to do that. We don't have to do this. And that's better because I want particle to be lighter weight anyway, because I'm going to have potentially thousands of these on screen. Okay, so we have particle, and I think we need a lifetime on the particle as well. That's what I think we need. So add particle is here. And I think it's going to be reasonable to I'm just thinking about whether I start the particle's lifetime in its constructor or I explicitly start it later. While explaining what I was thinking about, I've decided I'm going to start it in the constructor, but I am going to, we can change this later if we want to, but I think for practical purposes, this makes sense. So I'm going to say this dot birth time, I think, is equal to, I'm going to say now. And that means we're going to need a now in our constructor coming in. So let's do that, I think, at the beginning. So we'll say now right there, like that. And let's go look at where we're constructing the particles. Here we go. Add particle now. And guess what? Add particle is going to need a now, a time to that. That's going to need a now. Now, like that. And, oh, I commented out the add particles. Okay. Okay, let's declare this. I think you removed now yesterday because you don't have access to it. I feel like what I just did is working. I think I was remembering that. I remember what you're talking about a little bit, Will, but I don't remember if I removed it from the constructor or not. It seems like I just threw it all in there and added it. And I kind of feeling like that does make sense here. So here's my birth time. Is there we've got that. Now we need a lifespan on the particle, I think. However, lifespan is going to be held by the emitter. I think I've got a particle lifespan. I do not have that yet. So let's add that. I just used a duplicate line here. Particle lifespan, like that. And that's a number. And let's initialize that to this dot. Let's say that's equal to 5 seconds. Okay. And then we want to, no, let's do this. Particle lifespan in seconds. And I don't have to comment that out. Comment that as seconds. Okay. And then in our update, we want to pass that in from our emitter. Because we could have multiple emitters and update, so we're going to pass in the particle lifespan in seconds, which means we need to come out here, add a new number, VN again, and I'm just going to do that. Okay. Then I need a for loop after this because I need to remove particles that are dead. And so we're going to go from here to particles dot length, and then we're going to say we need a let particle equal this dot particles. Whoops. This dot particles of I. Oops, I wanted to go backwards. Hold on. There's a template. If I use an uppercase F, it takes me backwards. That's what I wanted to use instead. Like that. Okay. So now I'm counting down backwards because I'm going to be removing them is what I'm going to be doing. And then I want to say basically semicolon there. If particle dot has expired, we'll create that in a second. Passing in now. If it's expired, then I want to say this dot particles dot splice, and if I'm recalling correctly, it's going to be the start index, which is I, and the delete count at 1. So I'm going to remove that element right there from particles. So that's going to be remove expired. And let's go ahead and extract that class. And we're going to call that remove, whoops, let's rename it, remove expired particles. Like that. Okay. Yeah, again, when I see this and after I've done the extract method, I think, oh yeah, maybe I should do things, make things more private, because I'm like not really focusing on the visibility of these pieces at all, and everything's kind of defaulting to public. Let's declare this. Has expired. Let's drill into it. Let's move it. So now we're going to say, has expired. We need to We need this into it as well, right here in has expired. And like that. Oh, let's, I just realized tab to next reference isn't working, and it's because I haven't declared this type. There we go, now that works. Okay, so has expired. So particle lifespan in seconds. So basically we want to say vs age or lifespan seconds. That's equal to now minus this dot birth time. All of that in parens divided by 1,000. Right, so that's going to be in milliseconds. Divide the milliseconds by 1,000. That's now our lifespan in seconds. And then we're going to basically say, look, we're going to return our age is greater than particle lifespan in seconds. Like that. Bool return on has expired. Thank you so much. Right there. Good, good, good. Line 21 should be now minus this dot birth time. Well, wait. We'll change this to a let. What? Oh, that should be a number right there. Okay. That's what you meant to see. Now minus birth time. I think that's right now. You've got now minus birth time, but now minus this dot. Oh, I see it right there. Perfect. Thanks, Will. I did not see that. Okay. And lifespan seconds is greater than particle lifespan. So there's our has expired. Now, as it ages, then should I fade it out as these age? I kind of think that the opacity should be faded out as we age, is what I think we should do. Let's do this. Let's copy this line of code here. So we've got lifespan in seconds. We've got that here. Then we've got a percentage, you know, or we'll do this. If lifespan in seconds is greater than particle, you're going to need the particle lifespan in seconds passed in here as well, in draw. Like that. Okay, so lifespan in seconds is equal to now minus this birth time. Then we're going to have a number that is our percentage lived. So it'll be a number between 0 and 1. Also, we want to have a check, something along the lines of this that's like if has expired, actually. If, well, we could do this. It's a little, it violates my efficiency rule, but it's cleaner code. If this dot has expired, now, comma, particle life in seconds, then return. Okay. Otherwise we are running down here, and we're going to say percentage of the life lived. So is equal to, if I think we also need to argue as well, if now is less than birth time, then we're going to return as well. Okay? So if we're only going to draw if we're between equal to birth time or before our expiration date. That's when we're going to draw. So percentage lived is equal to lifespan in seconds divided by particle lifespan in seconds. Right there. So that should give us a number between 0 and 1 if these two are true. And if that's the case, then as we get closer to 1, we want to kind of fade out. So what I want to do is I want to say context dot global alpha is equal to 1 minus this. So if our percentage lived is 0, we haven't lived at all, it's going to be full on. It's going to be full on. And if we're almost near the end, it's going to be close to 1. It'll be global alpha will be close to 0. So now I can come in here and I can say global alpha is equal to 1 just to restore it at the end. Or if, to be more efficient, oh yeah, should I clean? Let's get clean. We'll do that. We'll strive for clean rather than efficient. Maybe particle lifespan seconds should be a particle property as you wanted above. I don't think so. And the reason why is because I think I wanted, well, it's only useful if we're going to have a different lifespan for every particle, or which is useful if you want to have a variance of particle lifespans, which makes it look more organic. Some particles might last longer than others. Yeah, I'm not 100% certain on that at this point. At this point, I decided to say no to it because I think it's a level of I think there's a heaviness with regards to the data that I'm holding for each particle that I'm imagining. So I want to keep that light if I can. And the benefit of making it more organic, we can achieve that in other ways by, for example, just changing the size, changing the velocity, that sort of thing. Will's saying he's just concerned about passing extra parameters around. I get you, but I think that this is kind of the extent to us doing that. But let's keep that in mind, Will, as we move forward, right? I think that is it's a good thing to keep in mind with regards to the overall heaviness of the API we're building too, right? Because there's that aspect to consider as well. So now we're going to have a natural fade out. I still want to build it so that in our update of our emitter, we actually we add the amount of particles we need since the last time. So what I need here, second since last update. We need to pass that in there. Second since last update is there. And particle lifespan seconds. Second since last update. Or wait, do I need that? Maybe I don't. Let's see. Last update time. Maybe I don't need the last update time anymore. I'm feeling last update time becomes seconds since last update. I like that better. And let's get rid of this and do that. And let's get rid of that and send in this. Whoops. So that's feeling a little bit better. So now let's go back into update again. And now what we want to do is we've got seconds since last update, and now we need to particles to create. That's going to be equal to seconds since last update. We need a particles per second, that piece right there. So that particles per second is defaulting to 500. So particles per second times seconds since last update. This dot particles per second. Then we want to basically, if this is greater than 0, well, actually we don't even need to say that. We can just say this dot add particles. Because if it's less than 0, this for loop doesn't even go. So I think we're good there. What's wrong here? Oh, now an amount. Okay. So we're going to pass that in. Okay. So that should create them. So if we're creating 500 per second and the lifetime is 5 seconds, we should see that thing above just swelling until it's totally roughly an amorphous looking circle that is that's about equal to the emitter's radius, which is set up where we construct it right here to be about 80 pixels. So let's maybe drop particles per second. Particles per second. Let's make that equal to 10 every second. So we'll drop it down a little bit so it will grow a little slower. So with that, let's see. Let's try refreshing the screen here and see what happens. See what we get here. Well, then it says, maybe let the particle have a reference to the emitter. I was thinking about that too. But I'm like, oh, it feels heavy. I'm trying to keep the particles lightweight is what I'm trying to do. Looks like that didn't work. Looks like we got a bug somewhere. So let's come back over to our instance of Chrome here that's running and refresh here and see what problems we get in the console here. Particle lifespan, seconds of undefined. What's my problem here? This update. Okay. Where's my call stack here? Oh, not paused. Oh wait, don't do that. This leads to lockups, I realized. I'm gonna have to particle. This is wrong here, my call to update. Let's just continue so we don't lock up. And whoops. The problem was, let's go back to console again. Line 47 of emitter.ts. So emitter.ts, line 47. This, the problem is particle lifespan seconds. Oh, it's the for each problem right here. I need the this binding there is what I need. Okay, I think that's going to help that. Let's refresh and see what we get next. Yeah, Will's getting it just before me. He's getting it before me there. Will says need to pass this to for each. Yeah, I'm still thinking about having it have a reference to the emitter. I am. Let's see where the heaviness goes. That's what I want to do on this. Hold on a second. I'm just adjusting my lights here, see if I can get a better lighting here on the green screen behind me. It says I'm paused in Visual Studio. What's going on there? Not sure why that happened. Okay, so now we do have some errors. There's another one right there, line 65 of emitter. Okay. Pass in this right here. And let's refresh. Wait, why is that not working? We should have just totally fixed that. Did I not save it? It looks saved. Let's try that. What is wrong? Why is this so slow and seemingly unresponsive? I did do a hard cache reload. I'll give that another second and see what, another few moments and see what happens. We only made 2 changes. We added the 2 thises there. It should totally work. And I'm expecting it to be totally loaded by now. Okay. All right, let's close it down and restart it, I think. Yep, let's do it. And let's kill all instances of Chrome. Bring them back. Try running one more time. No. What am I doing? Build errors. Okay. That could be a problem. Drone game. Oh. Let's take the emitter out of the drone game, I think. Let's take that out. So there I was just using CodeRush's tab to next reference to find the others, and I was hitting escape to jump back to it at the beginning. So it's just a quick way to get through and find all those and comment them out. Okay, so now let's see what we get when we start up. Looks like it's starting. There we go, look, and it's cool. So it's kind of exactly as I was predicting, right? We are creating these faster than we are clearing them out, which is kind of building this circle is what's happening here. Okay, cool. So let's go change our particles per second and drop it down. And when we move this, it's going to be fine because those particles are going to stay where they are and kind of fade away. But just to verify that they're in fact going away, let's go look at the Dragon game where we build the emitter. And let's say particles per second. Let's say we're going to put 1 in per second. So let's try that and see what happens. And I think it should still build up, but it should build up more slowly. Let's refresh. This I don't get. This seems to be taking a really long time here. Also, I'm right-clicking on Chrome, and I'm expecting to see the menu, and I'm not seeing anything showing up here when I right-click on this. Yeah, Will Bennett says, you didn't take the advice of the guy yesterday and added an infinite loop, did you? I don't know. I really felt like his infinite recursion idea, there was merit to that. Nothing makes me happier than, taking out the call stack, overflowing the call stack. Now look at this. Yeah, something is wrong. I feel like we do have an infinite loop in here, but I don't get it because I just added this. What did I do? I added this to 2 different pieces. My last 2 changes that made it go to an infinite loop were in emitter. I wonder if I am doing, I feel like I might be doing that somehow. Here's my update. Can I do a break over here? Yeah, I can't even get the right-click menu in here to get the inspect piece up here. Let's see if we can set a breakpoint and step through some code. Breakpoint, no symbols loaded for the current document. That's kind of weird and unexpected. What about Dragon Game? How are we doing in here? Nope, nothing there either. Yeah, it feels like it's in an infinite loop. So let me hit right-click on this, and we'll wait. What's going to be faster to find this? Yeah, let's look through. Let's kind of step through it. Let's do. We should be able. See if we can set a breakpoint here, and run. Close this down. I'm going to start the whole thing again, kill every instance of Chrome. Bring it back up. See if we can set a breakpoint there. It seems to be hanging before that. In fact, maybe we should set the breakpoint there. Right, here we go, starting up. Okay, good. So we are at a breakpoint. That's good. Let's go into Dragon Game. I'm hitting F11. There we go. And so nothing there. Stepping over that, stepping over that. Let's go into initialize. Creating the rocket, creating the gravity game. That's all good. Let's go into load resources. F10, F10, F10. So just stepping over each one of these. F10, 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 F10. Good. That works. Start. Update screen. And I hit F11. And update screen is updating. And it's working. Oh, and now, okay. So now I make no other changes and everything works. So it's almost like it was a refresh issue on it. We can kind of see the outer edges kind of fading off here. Let me refresh this a second. We should see this build up a little faster because of our stepping through. Hold on, refresh one more time. Refresh. There, we get to see him come up. All right, let's change the, in Dragon Game, let's change our particles per second. Let's make it 0.1. Is that right? No, maybe 0.4. So every 3 seconds, we'll put a new particle out. Oh, wait, I have one other thing. I just realized there's something else. We have a bug. Let me change it back to 1. Our bug is the particles are creating too quickly. And the reason they are is because of right here. Here. We need something to say if amount is less than 1, in other words, if it's 0.3, then we're just going to get out. The problem is we're adding a particle even if we've got a fraction, no matter what. And so we have to make sure that that we don't add particles when we don't have a full particle to add yet. Not enough time has passed. So now if we refresh, I think we'll see this come up a little slower. No? Why is that? Let's see what a hard reload does. Nope, still they're generating very quickly. That, I think, should have totally fixed it. Second since last update. Boom. Now minus last update time. Wait. Hold on. We have, well, first of all, what I'm seeing shouldn't happen, but the other problem we have is that our second since last update, the problem is that our update should be that we really need to be maintaining our last particle creation time is what we really need to do. So, hold on, particles per second. We need another number here, seconds since last particle creation, okay? And that's going to be equal to now minus this dot last particle creation time.
Nice variable name.
Thanks. And that whole thing divided by 1,000, like that. So seconds since last particle creation is here. And then particles created equals particles per second times seconds since last particle creation. Like that. That's what we need. Then we need here, and add particles, we need the last particle creation time is equal to now. Then we also need, we need to initialize this variable. And and I'm going to do it in the constructor. Do I have a now here? I don't have a now in my constructor for this piece. This is the thing I was playing with before yesterday. I think I took the now out. And there's my new emitter call right there. Loading resources. Okay, fine. I'm going to come in here. We're going to come in here and say or now, I think is what we're going to do. Yeah, look at this. I got you, Will. I've got a Will Bennett simulator in my head. Yeah. Second since last particle creation is there. Yes. So yes, and fine, we've done that. So second since last particle creation, so that can be 0. Particles create will be 0 there, and last particle creation time is there. So this gets us, I think, closer to what I believe is true, but I still feel like we have a bug somewhere inside of here, is what I think we have. So let's do a refresh and just see what our current behavior is with that change. There we go. Okay, so maybe that was just all we needed to do. Okay, I also think what's happening is we need to round
It
down.
compiles. Let's ship it!
Yeah, I want to do a better kind of, I want to do something different here. I want to say, let's do this instead. Let's say VN particles to create. Actually, I want it to be let instead. That's going to be equal to math.floor of amount, like that. And then I want to say if particles to create equals 0, then let's get out, like that. Because what's happening is I'm noticing we're getting 2 particles at a time here. And then that's my theory is that's due to the 1 plus the fraction. So if we refresh now, we should see only 1 particle show up. No, come on. Come on. Oh, there we go. That's my problem there. All right. So now if we refresh, we should see 1. There we go. About every second. Boom, boom. Good. Right? Is that what we set it to? 1 particle per second? Or no, we set it to something else. Let's look at Dragon Game, particles per second, 1. Okay, we did. So let's set it to 5 per second. And now let's refresh it. There we go. Okay, cool. So we've accomplished goal 1, which is let's give it a lifetime. And we've done it. So that's pretty cool. Let's change its lifetime. What is it? Particle lifespan seconds. And let's set that equal to 2. Let's cut it in half. And let's double this to 10. And let's see what it looks like. Cool. So that's kind of cool. We also might give it a fade in kind of time. Let's continue to mess with this. Let's put it at 30 and lifespan at 1. Let's do this. There we go. Cool. Let's go to 60 particles per second with a lifespan of a half a second. Nice, it's looking a little more organic. Yeah, that's kind of what I'm going for, right? And then now I want to give those pieces of gravity as well so that they move, responding to the gravity of the Earth. Well, then it says magic. Yeah, that's kind of what we're getting close to here is magic. Good. All right. Let's play with gravity next. So that also means, by the way, that now that we've got that working, that if we refresh our current view, we do this. There we go. We should see that kind of popping up over the live stream as we're writing code, which is kind of cool. And kind of distracting as well, isn't it? All right, so let's slow this down a little bit here. Let's drop these things down a little bit so it's a little more interesting here. Let's drop the emitter radius to make it smaller. Let's move the position, so instead of being kind of where the code is, let's try to get it right up in here, over in here, which my guess is about, this is 1920 across, so that's about 1400, maybe 1300. So let's say the X position's about, maybe we'll say 1250, and we'll bring that down. That's about, what is that? That's about 100 down, I think. About 100 down like that. And let's say particles per second is that. We can drop this down to 20, and we can create the lifespan so it's longer, like maybe 3 seconds like that. And let's just see what that looks like on this one before we refresh. Since this one's faster to load up, let's refresh it. Yeah, kind of close to where I want it. Let's make it to 180, and particle lifespan 2, refresh. Yeah. It's kind of cool. All right. So now if we refresh here, there it is right there. Okay, so it's kind of out of the way a little bit while we work. Okay, so now I want to get gravity into play on this thing. So it's been a while since we've done that, so I'm going to have to refresh my memory on this. Let's go to the emitter. And in our update call, we basically need to do that. So we need something we need to call out into our physics engine. And I think we're going to call get displacement, because we need this. Is now the time to change our physics engine? That's the question. Let's kind of consider that for a second, because this is something that Will was suggesting we do. Let's go look at the physics engine. And we might be able to, nope, it's not there. Game engine, physics. So we got get displacement. That works along a particular, yeah, so there's no dimensions here. I was thinking, let's work with vectors on here. I'm not quite sure I'm ready to do that yet. So let's see, back over here. So we want to say, so the particles, we actually want to do it in the particles is what I want to do. So let's go into here in the particles. And so we're going to say, let's make a call into physics dot get displacement. And the time is going to be seconds since last update. The initial velocity is going to be velocity dot x. Let's make it y instead, and the acceleration is going to be, I think I've got a global constant out here called gravitygames.active, and then .active, is that right? Where is, what's going on with this? There's my gravity games. What do I have? A property in here dot active planet dot gravity, I think it's going to be. So active planet dot gravity. Okay, so that's going to give us our displacement there, second since last update. So, so we need to, in order for this to work, this is our displacement since an initial point that we were on screen, given a particular initial velocity as well, okay, in the y direction. So what happens is we've got initially, as we bring the particle out, we're going to give it, it's going to have a particular velocity. If we look at the constructor for the particle, we're passing in the velocity of the emitter is what we're doing. And I have this to do here that says, consider ensuring velocity is along the same vector as offset. So like we could do something to the effect of saying call add and add in the offset. So what that means is that whatever that offset, physical offset is, the velocity is exactly is in that same direction, right? So when I say offset, so the emitters here, when we add a particle, the particles can have a variance from where that center is, and they can show up. And if they show up there, then arguably that should be its velocity. So then we add that velocity to it, so that's our initial velocity, so it has an x and y component. And then what we're doing inside of the particle is we want to then take that y velocity, whatever that is, right? Because the emitter could have a velocity that's going left, but I could put a particle above it, which means I want to go up. And so we're going to add those together, those vectors together, and maybe it's kind of going, the emitter's going up a little bit at the time. And so we've got that velocity going up. So that's kind of like what we're talking about doing. But what we need to do here is, it's just now occurring to me, that velocity in the emitter where we add the particle, this velocity is, essentially a, this velocity is going to need to be updated. We're going to need to update that velocity and recalculate it when we call add particle. So we're going to need a function here that says this dot update velocity. Actually, we want to do that outside of this. So let's get out of add particle. Here, add particles is there. So we're going to say this dot update velocity, and that's when we need to calculate it. Calculate the new velocity. I'm going to put a big I'm going to put a big fat implement this to do in here based on now. We need to pass in the now there. Whoops, that's not what I wanted to do. And whoops. Update velocity, pass in now. So we'll have a bug until we fix that. The bug will become evident once we start moving the emitter and we realize the particles aren't taking on its velocity, or they're taking on an older velocity. So, so we could do this, add, and we might also, you know what else would be neat, is to add a multiply, so we can reduce this by some particular fraction, maybe by 1 divided by this dot radius. So whatever this radius is, so we'll multiply by some number, and maybe, what's my problem here? What's going on here? Type particle. I think I just have an extra piece right there. Okay, so multiply, let's declare this in the vector, multiply. And multiply is going to basically just multiply both of these pieces by, it's going to return a vector, and it's going to say, let's grab that code so we can save some time. It's going to multiply both of these. So the idea is here is I want to, regardless of the vector size, I want to have some kind of even scaling out here. So depending on where it is, now what is wrong? Oh, this we have here, static. So no, it's not a static. It's, there we go. Okay, we'll put that up there. Okay, I think that's good. And so this right here, let's just do this for now. We're going to say max velocity. Let's say that's going to be equal to 5 meters per second. Meters per second, like that. And then we're going to say it's equal to that. And I think that's what that is going to look like. Okay, so kind of feel like I've jumped in. No particle reflection in your glasses. The illusion is broken, says Will. That's interesting. I might be able to get those, get that in there, but if I just angle it correctly here, because you are seeing some of the screen in my reflection of my glasses. But yeah, we'll play with that. All right. Okay, so I'm like at this point totally lost where I was headed with this. Oh, I want to get let's get things moving on here. So let's go into particle, and we've got our displacement. Our displacement is from an initial X and Y position, which we have here. And the draw is happening in the position right here, but we don't have the displacement. So we're going to have to keep track of our displacement based on the original position. I think that's what we need to do, and it's not going to be hard because these are as if they're thrown and then they go away. So what I need to do is I want to have this dot displacement X, displacement X, it's a type number, and displacement Y, also a type number. And let's get those spelled correctly. Okay. And then in here, I want to say this dot displacement X is equal to 0 and displacement Y is equal to 0. Just hit Shift Enter there to duplicate the line. Okay. And then now what I want to come in here and do is I want to come in here and say displacement Y is equal to this. Physics second since last update. There's our velocity y, and then our gravity. So whatever those pieces are. And with that, then I need to come down here, and I need to say position y, which is essentially our start position, plus this dot displacement y. And guess what? I should be making displacement a vector. Let's change it. Or wait, it does mess up here if I do that, but I'm going to do it. Displacement is going to be a vector. Okay. Let's come down here. Let displacement y number. Displacement is equal to new vector, 0, 0. I think this is not too bad. There's displacement y right there. And I'm in particle and particle. Yeah. I think that, whoops, none of that is what I want to do. I think that I want to add another piece in here. I want to say particle gravity. So I want to be able to have particles have a certain gravity, but I want the emitter to have a separate independent gravity. So I want to be able to take the emitter and just set it shooting out here and have a point in space and time that's my gravitational point, because I want to be able to spiral that thing in. Okay? But meanwhile, while that spirals in, I want the particles to drop down to normal gravity. So I want particle gravity to be a number like this. And I think particle gravity is always going to be down. Could it go up? It could be up too. So then I think I want to say particle gravity center point, like this, and this is going to be a vector. All right, like that. So Will's got a great suggestion out there. Let's create a static 0. So we're going to come in here, static 0, like that. And that's going to return a vector. And we're going to basically say return new vector 0, 0, like that. All right. And then now we can come back over. Where were we? Well, we need a gravity center. We need to work with that. But also, I think were we here? Where did we create that? Here it is right here. Vector.0. Like that. I think I want that to be a property instead. So let's go over to vector. I've got a CodeRushed template for creating properties. I think I can just do something like this. And just to get the syntax here, I really just want the getter, I think. Let's see if I can do this. Static getter, call it 0, like this. And then vector, and then I think everything else is this. Kill that. Let's comment this out. And I think I was doing this right here. Okay. That just gets me the syntax. It looks like that might be right. Which means now I can say vector.0 is a property, which I just like that better. Static read-only. Oh, that's a neat idea too. But well, then it says you can do static read-only 0 is equal to new vector. You're creating a new vector each time. Yep, you're right. Better to do the other one that way. That's much better. So let's do that. Static read-only 0 vector equals new vector. Yeah, every once in a while, Will, I notice that I write code as if I'm not thinking clearly. And I'm like, whoa, or I just don't have a, it's not like, oh yeah, of course that would be the better solution. So I really appreciate that, Will, jumping in like that. Okay, so there's our 0 there. I like that. That's even better. Let's get rid of this. Let's move this up to the top. I like to have my static variables up at the top above my constructor, my functions down below. Okay, so there's vector 0. Let's see, so there's my displacement. So displacement y is there. Then I want to calculate my displacement x. And that is going to look like that. But then the question is, what is the gravity here? We need to get the right gravity. And guess what? The particle needs to have a reference to its emitter. Right now we just crossed my threshold for this. So we're going to say emitter, type emitter, like that. We're going to refactor some code up here. So we are going to make that our new comma, that's of type emitter. And I'll make that public, like this, so we can lose that declaration right there. And so now my constructor looks like this. And then passing in particle radius. No, that's all good. I think we only needed the, let's see, what are we passing in here? So we've got position, velocity, radius, opacity. That's all local to this. Seconds is last time. Particle lifespan in seconds. We don't need this anymore. We don't need particle lifespan in seconds here, because now we can get that from the emitter itself, right there. Similarly, the has expired, we don't need that anymore. Right there. like that. And, oops, this dot emitter, like that. Okay. Nice, nice. Okay, next. The acceleration is the question that goes here. Well, I'm pretty sure in emitter, we just added a property called particle gravity. Let's do this. So, let's create a local variable here. We're going to call this gravity x, and we're going to create another one called gravity y. And all right. Oh, this is crazy what we're going to be able to do. We'll be able to, we can actually have the particles as well kind of orbit a different location in space and time if we chose to. If all of this math is working as I think it's going to work. So gravity x, or let's do gravity y first, is equal to this dot emitter dot, hold on, let's go back into emitter for a second. And let's look at where we were talking about adding particle gravity center. That's what I want to do. Okay, particle gravity center dot get y of get y component, maybe. And we're going to pass in this dot emitter dot particle gravity. Okay, so I'll show you this in a second. We'll add this get y component, and we'll get and get x component is going to look like the same thing. It's going to say get x component, and then we are going to declare it and declare that one. Whoops, declare that one as well. Jump in there. Thought I declared the x one as well. No biggie. We'll do this. And so now the idea is that if I am, if I've got an x and a y position, right, that my gravity is like, say, way down in the center of the Earth, and I'm very far away, right? What I want to do is I want to figure out the percentages that gravity is impacting my guy, is what I want to do. And so I just got to get the math right. I haven't quite figured this out yet in my head, but I essentially have a triangle that I'm dealing with, and kind of a distance away. And I think that it's equal to the x component divided by the total distance. So I think it looks like this. It looks like we're going to need another one, which is going to be, we're going to need another function in here, which is going to be length. Okay, so let's create a new function called length. And that's going to be Pythagorean's theorem. So we're going to return math.square root of this dot x times this dot x plus this dot y times this dot y. In fact, what I should probably do is, since these are read-only, is I should calculate that at the very beginning and make it a field variable. And then that way I don't recalculate every single time on that. Length of the vector, yes, that's what I'm doing, Will. Like this. And so declare it. That's going to be a number. And that's not equal to return, it's equal to math square root. Okay, so there's my length. And then, so now the y component, that's going to be equal to the ratio. So it's going to be equal to, this is going to be amount right here. And so then we're going to say return amount times this dot y divided by this dot length. And the x component is going to be this dot x. So now for gravity to work, what we're going to do in our emitter is our gravity center. So we're going to say this dot particle gravity is equal to, do we have an active game? Is it active game dot active planet? No, it's gravity games is what it is. Gravity games dot active planet dot gravity is the particle gravity. So we're going to set it at 9.8 meters per second squared because the active planet by default is Earth. Then we're going to say its center is going to be equals a new vector, and it's going to be equal to x position, which I'm going to say it's equal to screen center x. And the y position is, I'm going to say it's a really big number, like 50,000 meters, something along those lines. So it's very far away. So essentially it's going to suck down like normal gravity does. So that's kind of what I want to do there. But that also means that I could make this go up as well just by changing this to this other direction, I think, and it should work if I do the math right. That's like the big deal here, right? Particle, let's go over here. So now these are the get y component and the get x component. That's basically using the particle gravity center and getting the x and y components of those. And if I've got my signs correct, these items should fall down. And if I don't, we'll need to change that. But then we're going to say gravity y there and gravity x there. And then with these two pieces here, I'm going to now say my displacement equals new vector like that with displacement x and displacement y. And am I ready to test? That's the question. I think, let's see, there's my displacement calculated, and I'm taking it into consideration here. I don't have the x displacement here. Let's try it. Let's see what happens. Let's do a refresh. Okay, well, you're not, hold on. There's something happening here, but it's all off to the right side of the screen here. So it looks like not good. All right, so let's maybe set a breakpoint, see what happens. All right, so gravity x should be close to 0. Why is it? Oh, I have get y component. I need that to be get x component. Let's make that change and run and see what happens now. And okay, so it seems like there's some reset kind of thing going on here. Why would that be the case? Second since last update. Oh, this is second since last update. That update is the last time we took track of where our position was. So I think what we are going to need to do in our draw, nope, in our update, that's for our particle. Do we need to reposition? Maybe we do. Let's come down here. Let's change displacement here. Let's change this as well. Let's instead just come down here and say this dot position is equal to new vector this dot position dot x plus that, and this dot position dot y plus that. And then we want to say our second since last update, we kind of want to fix that, but I think that's going to be fixed automatically because outside the update, we say last update time, we set that here. What's going on here? What do I need? Second since last update, and we don't need the lifespan in seconds. And we don't need the lifespan in seconds here either. Okay. All right. Let's try it again, refresh. Looks like it's falling fast, is what I would suggest might be happening. That's kind of what I think is happening on there, is that it seems to be falling faster than we're expecting it to fall. Why is that? Or wait, I'm not sure. That doesn't make sense. Oops, I want to go to Dragon Game. And, nope, it's in the emitter. We had this default of, let's set a breakpoint and see what we get. Second since last update is very short. Particles to create less than 0. Now for each particle, we're going to update itself, and I guess who hit F10 instead of F11 like he should have. That's all right, I'll set a breakpoint. We'll go in here and we'll just double check what's going on here. Gravity X is way higher than I'm expecting it to be. Is that right? Where is what's our X position? Where's our position here? This dot position, our X, oh, it's pretty far off to the left. Negative 3,000. Why is it so far to the left? That doesn't seem to make sense to me. I wonder if displacement X, I think what's happening is that some of these are going way off screen. I think I want to say, let's run and let's refresh. And let's try setting a breakpoint here. See if we get any different numbers as we're coming through here. Gravity still is that, pretty high. And X is still pretty far off to the left. So let's do this. Let's not worry about displacement X for now. What's our gravity Y? Gravity Y is undefined. Let's just make sure that's close to 9.8. So that's 9.8. This is a little bit, fractionally, I guess that's arguably roughly what we are expecting to get for each of those. Second since last update. So now my position is here at the last update position. That all feels right to me. All right, I'm going to run it. Keep running it. Let's try slowing this down a bit just to see if this theory is correct on this. Let's set this equal to just 1 meter per second and see what happens when we refresh. So let's refresh. So kind of interesting, a couple things that's happening is our velocity, we've got our I think part of it's our velocity too. We've got this kind of initial velocity here. That's really bizarre. Yeah, let's go look at that multiply and add kind of thing that we've got over in vector. Oops, I didn't, let's see, I want to switch the order of these around right here. Slateboard says hello. And Will Bennett's asking about drunk particles. Will Bennett says it's the magnitude, the dot product. You're talking about the length of the vector? You think my code is incorrect there? When you say dot product, also I'm thinking you're just multiplying, but I'm not sure what dot product, I think that may have a different meaning than what I'm thinking about. All right, so let's do this. Let's in our, I think in our constructor for add particle, this piece right here was, I think, the deal, the problem, and velocity, let's take off the multiply call here, right there, and we're just going to add our own offset vector, and so that we even do that. I don't even think we should do that. Let's just pass in. Let me take all of this, and I'm going to change it to just this velocity right here. We'll put that in a comment there in case we need that later. Let's do that and refresh. Okay, still, it's like diving down really fast. Here, let's clear this out so we can only see the one here. So, yeah, it's crazy how this is dropping down way faster than I'm expecting it to. And so we've got clearly a bug in our update is what it feels like, right? With a gravity of 1, let's keep going. Let's say 0.01, or wait, let's do this. Let's just say divide by 1,000. Just see what goes on with that. Let's refresh. Yeah, Wilben says, I think you're updating for full seconds when the frame rate is sub-second. Yeah, that's why I kind of said let's divide by 1,000 just to see if it started falling at the rate that I was expecting to for planet Earth. But I'm pretty sure, let's say planet Sun. I think I can just type in bang sun to switch to the sun. Can I do that? Let's see. Have I done that? Yes, I've done that. Oh, but of course that doesn't change the gravity here. We're just doing the gravity of what's planet Earth there. So we can't, this is not responsive to that. Okay. So it's going to be in our update. The problem is clearly in our has got to be somewhere in our update. Seconds since last particle creation is equal to now minus that. Particles to create is this. Then we do seconds since last update, we call this. And seconds since last update, that's calculated outside of here. That's now minus last update time. Last update time is boom right there. Here's my problem. I think that's my problem right there. Let's see if that fixes it. No. Hold on. Let's just double check everything. It's now minus last update time divided by 1,000. Do I ever initialize last update time? In the start, I do, okay. So now update, coming in seconds since last update. There's goes into the particle, there's update, seconds since last update. Here, seconds since last update. Boom, boom. We get our that looks all correct to me. And did I get the I have a feeling the code is right. The code looks right to me. I just want to, why is it not, I feel like a refresh. Did it not get that save? Yeah, the code is looking right to me in that update call. Still not moving. All right. That does not make sense to me. So let's go to Dragon game where we create the, oh no, it's inside emitter where I create that gravity. Is it possible that that gravity that we're creating at this point in time is 0 now? That doesn't make sense to me. It's 9.8. Let's multiply it by 1,000 and see what happens, or multiply by 100 and see if we see movement. Nope, no movement. Why do we go from seeing movement to no movement at all? So the problem's not here. Yeah, it's just seconds last update there. Yeah, well, let's set breakpoints here and see what we get. Displacement X is incredibly small. Second since last update is also incredibly small. Are you sure where you divided time by 1,000 you weren't already in seconds? Floatplus Live says, hi, hello world, nice stream, man. Well, trying to make it a nice stream, trying to get this code to compile right now. We're creating a particle system in TypeScript, and yeah, we'll sing, are you sure? Well, right now, I'm not sure about anything, but the second since last update is really, it seems way smaller than I was expecting it to be here in the update. I'm expecting it to be, oh, wait, is it last update time? Okay, this, I don't think I'm using or need it. Yeah, let's get rid of these two, just clean these two up here. Clean that up there. Let's go back over here into update screen. I want to look at this one more time. So my now is there, last update time, that's equal to now. God, that should totally work. Basically we're looking second since last update should be, if we look at where it should be 10 milliseconds is what we're looking for. And when we set a breakpoint in there, that thing is it at 10 milliseconds? I thought it was like at a tenth of that. Look at where now is coming from. Is it already seconds? I don't think so. Let's go check that out though. Performance.now. Update screen. Yeah, no, it's coming in now. It's coming in at milliseconds right there. So that's what's happening there when update screen comes in Dragon Game, now is in milliseconds. So yeah, there's the last update time, and the last update time is in the same units. So seconds since last update is here. Refresh it and look for a breakpoint to be hit. What's happening? I get the feeling we're going to have to kill Chrome and come back. Seems like it's taking way too long. Oh wait, it says we're debugging. We're somewhere else. Hold on. What breakpoint are we? Oh, we're right here and we can't continue? All right, I think we're going to have to kill Chrome. And let's restart it. Oops, guess who forgot to kill all instances of Chrome so we can actually compile? There we go, I just did. Did I do it in time? I think I may have done it in time. Looks like it's loading it. No, wait, it says, oh yeah, it got it right there. All right, cool. For folks new to the stream, I have to, when I'm building, I'm basically working on an overlay for the stream, and when I'm doing that, I have to kill all instances of Chrome when I restart. Otherwise, the build won't work. Although, why are we at a breakpoint? Yeah, we're at a breakpoint. Okay, cool. So seconds since last update, what is this right now? that's a way more reasonable, interesting number right there. But I'm expecting, yeah, still nothing happening there. Let's do another breakpoint here. And what's our second to last update now? That is 10 milliseconds. So that is actually the right number. We're expecting that to be right. So that second since last update is good. Step into this. And gravity X is bigger than I want it to be. Particle gravity center. X is at 960. Yeah, I see what's going on there. Yeah, that's about a 50 to 1. So it is still bigger than I'm expecting it to be. So here my displacement on X should be very small. It is. My displacement on Y, it's a 1/10 of a second. Oh, I know what my problem is. I think I know what my problem is. I need to also calculate my velocity. I think that's my error here, is because I'm adding my displacement, but I'm not updating my velocity either. So I need to do that. So I need to say, I need two more numbers here. I think this is the problem. Whoops. New velocity. That's equal to new velocity x. That's equal to physics dot get final velocity. And our time is going to be second since last update, like that. And our initial velocity is going to be this dot velocity dot x. That's our x initial velocity. And our acceleration is going to be gravity x. I feel pretty good that this has got a shot of fixing the problem, that this is our logic error here. So there is new velocity x. Let's do the same for y. Just using CodeRush's duplicate line there, it just gets all of those for us. Oops, except for these two. I had uppercase and they need to be lowercase. Okay. And then I want to say this dot velocity equals new vector again. And we're going to say new velocity x, comma, new velocity y. Like that. That's updating our new velocity. Let's see what happens with that. Are we stuck in a debugging state? Looks like we are. Okay, let's refresh now. Stop, refresh. There we go. Okay, so now I see movement, but it doesn't seem like 9.8 meters per second. Let's extend the life. It seems like it's not quite right. The reason why I say that is because the scale is every 50 pixels is 1 meter. And the lifespan of the particles as we create them is, particle lifespan is 2 seconds. So in 2 seconds, if it should travel over, I would say 2 meters, it would drop down there. That feels like, yeah, it's dropped easily 2 meters in 2 seconds, which means a couple hundred pixels. It should be down here if the gravity is 9.8. And I think we've seen that that's the case it is. I don't understand that. So what's interesting is we did make those changes. Let's just play with this for a second. Let's just say times 3 and make sure that we're seeing gravity impact at a higher rate. Yeah, we are, but it's not, doesn't look right to me. We definitely have a small error somewhere. Let's go back into particle update. Look at that closely. The new final velocity. Yeah. I think, though, there's one other thing. We need a, it's not on particle gravity center. This is minor and doesn't have any, but it's not on the, it's on the delta between that, which we guess we could call subtract. This dot position, like that, like that. So it is, or it's rather this position minus the center, minus the emitter particle gravity center. Like that, I think is what it is. And what we can do here is we can say let relative gravity equal that, and then we have relative gravity dot get x component and relative gravity dot get y component, like that. So relative gravity is this position minus the other, so let's go declare it. And it's kind of cool because we've built this vector class and as we've needed the pieces for it. Okay, so return new vector, and it's going to be this dot x minus vector dot x and this dot y minus vector dot y, right, like that. So that's going to be that. That's going to have really no impact on what we're talking about, other than the x is, it's not going to drift just a little bit to left or right because of the x. So, okay. It's feeling right to me. This code looks right. Second since last update. I don't like it that it doesn't feel like it's drawing at the right, it's that the displacement is wrong. Let's do one other thing. Let's just make sure we're seeing acceleration here. Let's increase the lifespan to, like, say 8 seconds as well, and do a refresh out here and watch him. Oh, look at that. That's like totally awesome. And it looks like I have, it's this minus that. So hold on, that's my subtract call. Did I really get them wrong in the subtract call? So if gravity is here, here, no, I did get them wrong. It's the opposite of this. It's this calling subtract on that, on the position. Let's try refreshing that. Okay, so now they should drop down. And yet if we drop a seed out, that's how fast these should fall. So we have a bug somewhere. Although I love kind of the look and, you know, how it is. It's definitely getting that kind of organic feel. The only thing I'd want to change is I'd want the particles to fade in rather than just pop up. So here's what I think I'm going to do. I think I'm not going to try to chase after this bug right now, because I feel like I've spent a fair amount of time on that. The code looks right to me. I think it's a more elusive bug. It's going to take more effort, and I don't think I want to spend the stream's time doing that. But I think I do want to do one last thing here before we give away a copy of CodeRushed, and that is I want to fade these in as they come in. I want to give them just a little bit of a fade in time. And I want to specify that as a property, I think, of the emitter. So let's do that. So we'll come into emitter. We're going to add a new property called particle fade in time. And that's going to be a number. And we'll set that by default to 0.4 seconds. And then that's in the emitter. And then so now in the draw function of the particle, we want to do something along these lines here. We want to basically say, look, if seconds alive is equal to now minus the birth time, like that. Smokestack, return value for subtract should be a vector. Did I fail that? Looks like I failed to specify that. What did you, yep, that's exactly right, vector. Good job, Will, thank you for spotting that. Similarly, let's change these to numbers and change this to a number as well. Yeah, I'm using the declare method part. It's not, Visual Studio's declare method is not as smart as I want it to be. That's an opportunity for CodeRushed to come in here. So seconds alive is this. Let's also replace this calculation here with simply seconds alive. So we are, this should be milliseconds alive actually. Make it time alive milliseconds like that. Okay, and then we've got that. And then I want to say if time alive seconds, that's equal to this divided by 1,000. Okay, so if time alive seconds is less than this dot emitter dot particle, fade in time. So if it's less than the fade in time, then I want to come in here and I want to set its global alpha to that percentage of percentage born is what I want to call this one, I think. So we'll do this, percentage born, and that's going to be equal to, time alive in seconds divided by this emitter.particle fade in time. Well, then it says, I think you need to use an easing library for all these fades. We'll simplify the code. I've been working on one. Interesting. Yeah. So great suggestion. Interesting suggestion. Actually, Will, what I had planned to do was create a keyframe library. And the keyframe library would allow me to specify points at which I want, like, for example, opacity to be adjusted. And I think it'll be really fun and cool to do this for JavaScript because it's not hard to say, let's modify this particular variable of this class by name at this particular time. So I kind of want to do that, although I have not, in my mind, I was thinking, well, I'll just ease them in linearly to begin with, and I won't do like a Bezier ease in initially because of the math, and because I think I can still get it close enough to looking organic with a short span of a fade in or fade out. But yes, you're right. We're totally doing linear transitions here. This idea of adding an easing or using an easing library, yes, but I want to do it from scratch just because that's what everything we've been doing is from scratch. And so that's interesting to me, right? Building what's good enough to exploit and in the process of creating this. So yeah, we won't do that now, but I do plan to have a keyframe, add a keyframe class, and to have, to be able to specify externally what my transitions are for different individual properties. And based on those times, then set those up. But anyway, we're going to do this. So percentage born is equal to time 11 seconds divided by the particle fade in time. And then we're going to say this global alpha is equal to percentage born. So I'm going to say that. However, what about this? I guess I'm going to do this. We're going to need a big fat else here is what I think we need. And we're going to put that like that. So I think that's what we're going to do. So that'll get us our fade in or fade out right there. That block of code right there. Calculate opacity. Let's extract that method. Call it, rename it, calculate opacity. Like that. Let's swap the order of these parameters just so they're consistent with what we're calling from, with our calling function as well. Okay. And I think we're good. Calculate opacity. So, good. Now, if we refresh, we should see these, instead of popping, right now they're popping. If I refresh it, now they fade in. Nice. So it looks more organic. And we still have that one last bug, right? If I come in, here, let's come back and let's go to the main view here. We'll remove this and just look at the stream overlay. So there's the stream overlay right there. Now I've got the particles dropping down up from the ceiling there. And yeah, by the way, Will, if you've got some sample code for that makes the easing code, you figure that out, I think that'll be totally appreciated and exploited and incorporated with your permission into the show, because I think we need to do that. But for right now, we're kind of hard coding this linear transition here. The linear is essentially by this, done with this division right here and this division line right here. And so now we've got that kind of, that kind of dripping kind of thing there. We have to figure out gravity. I'm going to look at that, but I'm not going to spend the stream's time on that. And hopefully we'll be able to figure out what's going on with gravity, why it's not falling at the same expected rate. It feels and looks absolutely correct to me. There's something I'm missing, something I'm clearly missing here. Something, I don't know what it is. All right, I think with that, let's give away a copy of CodeRushed, because you know what time it is?
You know what time it is?
It's time for another CodeRushed
CodeRushed giveaway!
That's right, and today's winner is
Brave Cobra 2.
Brave Cobra 2. Congratulations, Brave Cobra 2. I will DM you right after this stream here and give you download instructions, tell you how you can get download instructions for your copy of CodeRushed. In general, I think not a bad stream today. I really would have liked to get these things dropping at the right acceleration. They are accelerating, but not at the speed I'm expecting them to do. So we'll look into that, try to have that bug fixed. And I think if on my calculations, an awareness of the temporal awareness is correct, today is Thursday, which means we will see you on next Tuesday. That's when we'll be back. Will, by the way, puts this in the chat room, says this is what I'm working on right here, and in terms of his easing right here. Oh, wow. Look at that. Okay, that's definitely a lot further ahead than where I was going to go. Very, very cool, very interesting things. So yeah, so I think I'm going to add a keyframe class, and then I'm probably going to also add like an easing class as well. And we'll start off with implementing a linear easing, and we might add some of these others. So this might be something else that we come in here and add. That's pretty cool, Will. Appreciate the link for that. And that link's out there in the chat room. So with that, thanks to everybody. We expect to see Roy, I think, next Tuesday, maybe next Wednesday. And until then, hope everybody has a good holiday vacation and break. And we will see you next time.